And the floor is yours, and thank you for being here.
Thank you, Mike. I'm going to be talking without a microphone. Can everybody in the back hear me?
Yeah.
Perfect. All right. Yes, I am Jim Mills, and I'm here with my wife, Beth Myers, who's handling all the electronics. And the guidance that has been given to all of us over the last several months for these presentations is talk about something that you're really passionate about. As you can tell by the title slide, I'm passionate about petrified wood. I've been collecting probably for 20, 25 years, but been a rock hound since I was probably 8 years old, and I'm not going to tell you how many years ago that was. If you've been reading any of my ramblings in the Did You Know column in the monthly newsletter for the club, then you know that in addition to what I collect, I really like the background stories that accompany the rocks. So really what I want to talk about tonight is what I actually have an even bigger passion for. And that's collecting knowledge. Knowledge that I think can be just as exciting as collecting the rocks themselves. But of course, I'd like to have the rocks as well, right? Here's an interesting cartoon. It's one of my favorites. Came out of the Fort Lewis newsletter a couple of years ago. And you can see a couple there with a broken pickup truck in the back. And of course the pickup truck is broken in half because it is so loaded down with rocks. And she's saying, just one more piece, you said. Well, I knew this was going to happen sooner or later. But I have a question for you. What if the truck was empty? If the truck was empty, would that have been an unsuccessful trip? I'd like to talk tonight about fossil forests where collecting is either prohibited or extremely limited. And there are lots of those. I've listed some on the graphic up here. I like to go to those places. And when I go to those places, I like to try to explore the geology in person on the ground. And when I say explore the geology, I'm trying to get a good feel for how the geology fits in with the topography of today. And how did it get to be that way? Now, when I take a trip, this is my strategy. If you read that, you're going to say, well, that's pretty simplistic. That is not rocket science. No, it's not. You read in advance, you go on the trip and develop some questions, you come home and you look around, see if you can't answer some of those questions with some research. But how many of us have gone on a trip, last minute, didn't do a bit of reading, got out there in the field, maybe with a group, had no idea what we were really looking for. Well, what does it actually look like? Where is it actually occurring? Is it on that hillside or is it on the other hillside over here? So what I'm going to try to do tonight is to convince you that this is actually, as simplistic as it is, a pretty good strategy to follow. So let's talk about, for a minute, reading in advance. And I'm going to put all of this in the context of my favorite subject, which is petrified wood. But I guarantee you that you can really substitute anything that you collect, whether it's agates or jasper, whether it's minerals or fluorescence. You can substitute any of those things in for what I'm going to be talking about tonight and come up with pretty much the same conclusions. So here's some of the things that I tend to look at before I go out on a trip. Information sources. Some of them are in what I would call the popular press. Here's a book by Frank Daniels. It's called Petrified Wood, and it's about fossilized wood, cones, seeds, and cycads. It's pretty much of a coffee table book. You open the book, and incidentally, I brought all the books that I'm talking about tonight. I brought a copy. You're welcome to come up and thumb through them afterwards. you'll find that it's all photographs. The only text in it are the captions. But it's still a really great resource for two reasons. One, it gets your blood flowing. Whoa, I'm jazzed about getting out on this trip now. And two, it can give you an idea of what is really possible at different locations. That's what people would actually photograph and put into a book. I hope I can find something like that. Frank wrote a second book. He's not real creative with his titles. The first one was Petrified Wood, the second one was Ancient Forests. But this time, he wrote it with a professional geologist, a geophysicist, in fact, a fellow by the name of Richard Dayball, who is also a really, really ardent collector of petrified wood. So the book is about 4 times as big as his first book. Dayball did all the writing, and there's a huge amount of text in it, and so I would say it's way more advanced than the other one. It would take perhaps a few more pages to get your blood flowing, but you would learn a lot by looking through there. There's also some books that are what I would call site-specific. Here's one by a German author by the name of Ulrich Dernbach. He used to be a dealer in petrified wood and sold at the Tucson and Denver show. And it's subtitled The World's 31 Most Beautiful Petrified Forests. It's definitely the book you would want to look at if you were going to visit any of those forests. It's got great photos, it's got interesting adventures, and it's got information that you can really use to plan your trip in advance. Now, for the more technical information, there's a lot of U.S. Geological Survey publications that deal with specific genera, specific species, etc. in petrified wood. You can also find the same thing for agate locations. You can find the same thing for jaspers and various minerals. Most of these are out of print. If you've noticed anything about USGS these days, they're really in the business of hazard analysis. They live and talk landslides and earthquakes and an occasional tsunami. They're really not doing any what I would call basic science in geology anymore. And their new publications reflect that change in focus. But the old publications are always available through used book dealers, and some of them are even available for downloads on the internet. For those of you that really want to get technical, there are some books out there that deal both site-specific and genus-specific and cover all of, in my case, the petrified woods from a particular location. This one, Woods of the Eocene Nutbeds Flora, up in Oregon, is extremely detailed, it's extremely technical, and you have to be as obsessed as I am to consider this good bedside reading. But if you really are into petrified wood in a very big way, it's a fantastic resource. Now here, there are books out there that it really doesn't matter what kind of rocks you collect. They're useful to everybody. And I've picked as an example here of State of California Department of Natural Resource Division of Mines book on the geology of the Barstow Quadrangle. And the reason I picked Barstow was because Barstow's got it all. I can go out there and collect petrified wood. You can find jaspers, you can find saginite, you can find minerals, you can find insect fossils, you can find just about everything imaginable, including vertebrate fossils, which are illegal to collect. Okay? So it's a really good book. It covers a small area. It covers 1/4 of a degree of latitude and 1/4 of a degree of longitude. In more technical terms, that's 15 minutes of latitude and 15 minutes of longitude. So that's not a big area. The really good thing about these kind of publications is they always come with a map, a geologic map. And you should know how to read geologic maps, because if somebody gives you some directions and said, you could find, fill in the blank here, this out in this particular area, follow these directions. And if you went out there and you found a couple of chips or a couple of shards of something, and you said, I got to the place, but I must have gotten there too late. because it's been cleaned off by everybody else. Where else could I look? That's when your geologic map would be extremely handy, and you'd want to have that in the field with you so that you could say, look, this particular strata also outcrops 1.5 miles away down this canyon. And so you would follow that, and you'd have a better successful trip. And of course, no discussion of information sources would be complete unless you talk about the internet, right? So if you have your typical Google web browser and you Googled petrified wood, hey, you'll get a couple million hits. Most of those people will want to sell you some petrified wood. Probably the next most prevalent group of people are people who are blogging about petrified wood. And some of them even know something about it. But it's kind of hard to separate the fly specks from the pepper in some of those blogs. And so what you really want to do is think about using Google Scholar. Google Scholar is a search that only looks at academic and technical documents. And you could put in anything. In my case, I could put in fossil wood, and I would probably get 5,000 or 6,000 hits. If I put in something like the Chinle Formation, or locally here, the Monterey Formation, I'd probably get way less than that. Maybe something on the order of 800 to 1,000 hits. If I put in something really specific, and I said Aracarioxylon in the Chinle Formation, I would find I'd probably have about 100 to 150 hits on Google Scholar. And that's a manageable number. That's a number that I could actually look through and find information that's really valuable for what I am interested in. So now that we've done our reading in advance, let's take a virtual journey in a virtual pickup truck, if you will. And we're going to I'm going to cover 5 different localities, petrified wood localities, not necessarily collecting localities. Okay, but 5 localities that I think collecting the knowledge and information at these localities is just as exciting as bringing home a lot of rocks. So, starting out at the Petrified Forest National Park in Arizona. Now, most collectors would look at that and say, that's the gold standard in petrified wood. That's the kind of wood that you would like to find out in the field and bring home, right? It's old, it's colorful, it's round like a log. You can actually see the expression of the rays coming out, the black pattern there, and you can actually see the center of the log itself. So it really looks like wood. What I like to say, it's the kind of thing you can see from across the room and identify it as petrified wood. And even a novice would come to that conclusion. So here's what we'd all like to find, right? Big logs like that, aren't those fantastic? We would love to bring one of those home in that cartoon pickup truck we looked at a minute ago. But the National Park Service frowns on that. They do more than frown on that. It's a felony, and they will arrest you. Remember, there are no federal misdemeanors. There's only felonies in the federal judicial system. So you definitely don't want to be collecting at Petrified Forest National Park. The whole point of Petrified Forest is for your grandchildren and your great-great-grandchildren and your great-great-great-great-great-great-great-grandchildren to see the Petrified Forest exactly the same way that you see it today. And so it's also there to provide a research refugium for geologists in the future. So we want to keep the future beneficiaries in mind. And here I've got a little map of the Petrified Forest boundaries here. Here you can see Holbrook over on the left. You can see the Navajo Reservation on the north. What's useful to know here is that you don't want to collect in here. The Navajo police don't want you collecting up there either. There's a lot of gray on that map where you could be collecting. And if I were to show you a map that showed the Petrified Forest portion as just a tiny little thing, with 40 miles out in every direction, north, south, east, and west, there'd be a whole lot more gray where you could actually do your collecting. So what's the point here? The point is that a visit to the Petrified Forest National Park Visitor Center will give you an understanding of what the petrified wood history is, what it looks like, and believe me, it's not all red. There's a wide variety of colors in the different members of the Petrified Forest strata. And so it'll also tell you what the habitat looked like when those trees were alive and well. And so what you really want to do is understand what you're going to be collecting later on in the gray areas out there, so that whatever you collect will have some background stories behind it, and it'll be a whole lot more interesting to other people to whom you are showing your collection. So I brought along here an artist's rendition of what the Petrified Forest looked like during Chinle times. That's Triassic. It's 225 million years ago. You know, when I show this picture to people, usually the first thing they look at are the reptiles. Those are not household pets. Those are reptiles with really big teeth and really big appetites. But behind the reptiles are really big trees. They're all the same family, the Araucaria family, and through the entire Mesozoic, which covered a period of time from about 240 million to about 65 million years ago, they dominated the Earth in terms of large arborescent life forms. They were the group of trees. And there were probably thousands of those trees, or thousands of species of those trees, through that long period of time. Today, there's only 12 left. That's something you would learn at the Petrified Forest National Park. There's not only just 12 left in their natural habitat, they're all southern hemisphere. Not one of them occurs in the northern hemisphere anymore. But they were dominant during the Mesozoic period, and so that's worth knowing and worth being able to tell somebody when you're sharing your collection. Okay, let's move forward in time a little bit west to a place called Brown Butte. Brown Butte was a Miocene marshland. It's out in the Mojave Desert. Here's the town of Mojave, and here's Edwards Air Force Base, where the space shuttle lands, Highway 58 coming this way, and the 14 going down to Los Angeles. Okay? It's really conveniently located. That's a good thing and a bad thing. One of the reasons that it's not a very good collecting area anymore is because it's really conveniently located. Over the last 75 years that this spot has been known, there have been 50 to 75 different rock clubs in the Los Angeles area who said, well, let's just go up there on Saturday for a club outing. It's only an hour and a half drive away. And so you can imagine the tens of thousands of rock hounds who have gone over that area already. What is special about Brown Butte? Why would you want to go there then if it's already been sort of vacuumed up? Because even though cattails are found in the fossil record all over the world, they're found mainly as compression-impression fossils. That means that during a flood event, a cattail was forced down into the mud that it was growing from and covered over with more mud. Eventually, that mud was compressed, it became mudstone, and you can come along, crack that mudstone with a hammer, and make it open up on the cattail, but it's only two-dimensional. You just see an impression of the cattail. It's not really there anymore. And at Brown Butte, the cattails are silicified, and they're three-dimensional. You can actually see how that cattail looked. So it's a really important site. There are a few more of those in the world. This is probably the best one, or was the best one in the world. Here's a cattail in cross-section, and what I really want you to notice here is right in the center is the pith. That's the part that has the brown top on it with the namesake cattail, right? And then all of these little boxwork structures are the leaves. Those are very, very diagnostic of cattail leaves. In fact, they're so diagnostic that I went out on my farm pound and I cut one down, took a picture of it to show you that it's identical, isn't it? Here's the center pith, and here's all that boxwork in those individual sheathing leaves. Sheathing meaning they clasp around the center stalk. And here's a cattail from, believe me, it took a long time to find this. Here's a three-dimensional cattail from Brown Butte. I'm pretty sure that this was thrown away or perhaps just dropped out of the backpack of one of those tens of thousands of rockhounds over the last 75 years. And I just happened upon it fairly far away from the marsh itself. But this is what it used to be a long time ago. And here's a picture of my farm pond, the upper end shallow, cattails growing everywhere. It's wet all year, and it's green. And here's Brown Butte, and the cattails are up here. Now, if it takes wet for cattails to grow, and by the way, cattails can grow in 30 inches of water, they need water. If it dries up, they'll dry up as well. So, how did those cattails get up there? And that's an interesting story. 12 million years ago, during the Miocene, that was not a butte. That was not a mountain. And during the Miocene, the Sierra Nevada mountains were being pushed up to 14,000 feet by plate tectonics. And the Pacific plate was diving under the North American plate and pushing up the Sierra Nevada. But in the lee of that Sierra Nevada mountain chain were all of these ripples that we now see as smaller mountain ranges in the Mojave Desert. And they ripple all the way for hundreds of miles. Almost all of them trend almost exactly north and south and parallel to the Sierra Nevada. That's an interesting story to tell, and it's an interesting story to see on the ground. This is what it looks like up on top of that ridge. Each one of these small circular structures that you see is a petrified cattail. Now, I'm told that in the mid-20th century, those were all 5-6 inches tall, and they all stuck up individually out of that agate marsh. That hammer was not the hammer that knocked them all down, but I bet it had a lot of hammer cousins that did the knocking down. And probably a lot of those cattails ended up being just crushed and thrown into tumblers in order to make costume jewelry in the 1940s and the 1950s, maybe even into the early 60s. And so, basically, for collectors, all of the cattails disappeared. There is still the base of them that you can see there, and some of those stick up a ½ inch or 3/4 of an inch. But wouldn't it have been nice to see all of those sticking out? It probably would have made a nice state park had they done it early enough. Personally, I don't think I could feel too good about hammering it out. Now here's what Brown Butte looked like during the Miocene. This is Saratoga Spring. It's on the extreme southern boundary of Death Valley National Park. And Saratoga Spring has got the very same vegetative assembly that Brown Butte has. It's got cattails, it's got Tomlinsonia grasses, it's got reeds, it's got rushes, all the same genera that you can find at Saratoga Springs are found at Brown Butte. And what's important about that is that is what paleobotany is based upon. Paleobotanists go out, they excavate plant fossils, and they make long lists of all of the genera all of the family affiliations, all of the species. And when they get that long list, they also try to get a statistical sample. What percentage were cattails? What percentage was grass? What percentage was rushes? What, et cetera, et cetera. Then they go out into the real world and they look for the same plant assemblage living today. And once they find one that's either identical, not very often, or close, usually, then some interesting information can be obtained. What is the geography like? What is the climate like? What is the latitude that it's growing at? And you can begin to make some very interesting conclusions about how that Brown Butte area looked 12 million years ago and where it was. Okay, let's take our virtual pickup truck, park it at the airport, and take a virtual airplane over to Coldstream, Scotland. A few years ago, some of you may remember, I gave a presentation entitled "Geology Geek Goes to Scotland," and we went to Coldstream. If the name Coldstream rings a bell with you, it's probably because you've read it in the press before about the Coldstream Guards. Coldstream Guards is a British infantry regiment which has hundreds of years of history of exceptional valor. We knew that, but we didn't know anything about geology in Coldstream. And so we went for the history and for the village itself. It's a beautiful village. It's on the River Tweed. You can see over here in the corner. And it's a really pretty place. While we were there, we picked up a brochure that discussed a place called Charlie's Brae. And Brae in Scottish means woods. And Charlie was a professor at the University of Edinburgh by the name of Charles Witham. And in 1831, Charles Witham was the very first geologist to make thin sections out of petrified wood and study their anatomy. Did I hear a question? What the heck are thin sections? Glad you asked. Thin sections are very small, very, very thin portions of a rock, in this case petrified wood, which are ground down to only several microns in thickness. That means for petrified wood, it's just a couple of cells thick. It's very, very thin. And in doing that, you can actually make microscopic slides like these. And I brought along some tonight if you want to take a look at them. These happen to be from Oregon, not from Coldstream. And this is what it looks like. I didn't bring my microscope, but this is what it looks like through the microscope. And you show this photograph to anyone who understands wood anatomy, and they will say, that's an oak. Of course it's an oak. It has really wide medullary rays. They're more or less evenly spaced. It's got really large water vessels at the beginning of the growth period. Each one of these is actually the annual growth ring. It has smaller growth rings in the summer wood, etc., etc. And that was a really important discovery by Charles Witham. So, since Beth and I do a lot of microscope work ourselves on petrified wood, you can imagine we were really excited to take this trail the next morning and go see Charlie's Brae. Well, unfortunately, it is Scotland, and the weather did not cooperate. So that our adventure turned into kind of a rain-soaked trudge. And there I am, standing in the middle of what is now a cow pasture, not a woods, thinking to myself, if I had just packed my shovel in my suitcase, I could dig down and find the rest of Charlie's log. Well, we didn't do any digging. We did look around underneath the trees. There were some piles of wood, or some piles of rocks, and a lot of cow pies, but no petrified wood. So we came up empty-handed. But we also determined that the lord of the manor house right next door probably would not have appreciated us digging in his cow pasture anyway. So, but we were perfectly happy to have had the experience of being in a place that was historically significant for our particular collecting hobby. So let's come back on our virtual airplane and let's go to a place where there is nothing to collect, nothing at all. It's the lava cast forest, and it's in the Deschutes National Forest, just 7-8 miles south of Bend, Oregon. And the reason that there's nothing to collect there is that there's nothing there except for these cylindrical holes in the lava. But the way those holes got there is what makes it interesting. These are the molds of trees that were growing in place when the lava came through. Some of them were standing, some of them were recently downed logs. That's not a very old deposit. That came out of Newberry Crater, which is maybe 15 miles to the south. And it's only about 12,000 years ago that it erupted and created this lava flow. But wood, if you work with wood, you know it has to be seasoned. Or even if you burn firewood, you know it has to be seasoned. And the reason it has to be seasoned is that it's got a lot of moisture in it. It's got a lot of water in it. Well, those living trees had plenty of water, and as soon as the lava hits it, a very thin layer of lava around that tree begins to cool to the extent that it actually forms rock. Once it becomes even a thin layer of rock, it actually acts as an insulator against the heat of the rushing lava to the side. And eventually, the tree, if it doesn't incinerate, and most of them do not incinerate, but eventually, what happens to the tree? It's still sticking out of the lava. It's still, whether it's horizontal or vertical, and eventually the bacteria and the fungus that's working in the forest does the same thing that it does to a deadened down log. It eventually just macerates it and it disappears. It just turns back into dust. So it's a really interesting area. Here's a more recent example, because it still has the wood in it. There still has a really long tree trunk covered with lava. And that's really only a few hundred years ago, that particular lava flow. That eventually will disappear as well, and it'll leave, in this case, a horizontal hole. One of the things I really liked about the lava cast forest in Oregon was that the Forest Service had paved a nice pathway through it. And if you've ever walked across lava, you know that it doesn't take very many miles to wear out a pair of boots. It'll just rip them to shreds. And so it's a really convenient place to get a good understanding for what happens in a lava flow when it's coming through a forest. And of course, the Forest Service didn't even have to put up a sign that said no collecting, because there's nothing but air inside those tunnels. Okay, moving on to my last item, or my last locality, is a place called Badger Flat in Humboldt County. And what I've shown you here is one of the rarest fossil woods that you can find. It's Joshua tree. It's fossilized Joshua tree. It's Miocene in age. It's one of the earliest Joshua trees that could ever be found. And indeed, it's only found in one place. It's only found in Badger Flat in Humboldt County in the far northwestern corner of Nevada. Now, the old-timers call this wagon wheel wood for obvious reasons. It looks like it's got a hub in the center, and it looks like it's got spokes coming out and a pretty good-sized tire going around it. That gives you a clue that Joshua trees don't grow the same way that real trees do. Incidentally, Joshua trees are members of the lily family. It's not really a tree at all. It's just a great big lily with a good-sized trunk. This is what Badger Flat looks like today. No Joshua trees there. It's way too cold there now. Yes?
How long have these trees been gone?
This is Miocene in age. It's about 12 million years ago. So these trees, these trees have been gone for a long time, partly because it's just way too cold in the wintertime now for Joshua trees to survive. Remember, I said it's a lily, it's not actually a tree. Yes?
And how far do Joshua trees extend north into Nevada? Because it's all juniper up in that area.
They don't go up that far at all anymore. Now you can get as far, I think you could probably get as far as about 100 miles north of Las Vegas. And that's the furthest extent north that you will find Joshua trees. So this is what you hope to encounter at Badger Flat. This is actually a piece of Joshua tree. I'm pretty excited. I'm almost too excited to take the picture before I pull it out of the ground. But I did control myself and take the picture first with my rockhound hammer. But that is how it occurs. But there's more than just the fact that it's really, really, really scarce. Probably over all rockhound history, there probably has not been more than 1,000 or 1,500 pounds of Joshua tree found total. And most of it, I think, has already been found. There's not a lot left. So there's a mystery associated with it. In addition to the Joshua tree, you can find elm, you can find dogwood, you can find conifers, and you can find willows, and you can even find oak. Now, here's an absolutely perfectly typical stand of living Joshua trees today. This happens to be on Walker Pass, just to the west of Ridgecrest, California. Do you see any oak trees? How about willows? Any conifers? You see any trees at all? Definitely not. There are no trees these days that share habitat with Joshua trees. So why is it that when you go collecting fossil Joshua tree and finding a piece, if you're really lucky, why is it that you find all of these other species along with it? I don't know the answer to that. If the answer is not at all clear, I mean, there's plenty of theories around. There's a theory that it's all been washed in from somewhere else. That theory doesn't really hold up because most of the pieces that you find still have some of the volcanic ash attached to it. And that ash would be the first thing to go in any kind of a transport situation if it was water washed. So that's probably not the case. Maybe the Joshua tree during the Miocene 12 million years ago had totally different habitat requirements and was totally different than the Joshua tree today. Well, maybe, but probably not. An interesting story is that when the taxonomy of the anatomy of this fossil Joshua tree was written and was out for review amongst a whole cadre of paleobotanists, it turns out that the printer made an error and switched the photographs of the anatomy of the fossil Joshua tree with the anatomy of the living Joshua tree. And it was only at the very last minute, after everybody had reviewed it, that the error was discovered. Because they looked exactly identical. And people couldn't tell the difference. They just couldn't tell the difference. So maybe it was marginal for both the Joshua tree and for the other tree species. Maybe it was already beginning to get too cold for Joshua tree. And maybe it was already beginning to get too arid for willows and oaks and the rest of it. But they were still hanging on together in sort of the same area. That's a possibility. We don't really know. Wayne, you had a question?
Don't willows need quite a bit of water to grow willows?
Absolutely, absolutely.
So could it be an oasis?
It could have been, but I've never seen a living Joshua trees stand
Right.
near standing water. There aren't any. Now, having said that, that doesn't mean that there weren't some in the past. So that's a good question. So we don't know. I've brought along a Joshua tree fossil on the left there, and a living one on the right. The living one, incidentally, is courtesy of Galen Moyer there in the back, who brought that back from a recent trip, and is a perfect specimen. It's a great specimen. Notice that they have two distinct cylinders, the primary cylinder and the secondary cylinder. And as that cylindrical, both of those occur immediately when the plant sprouts. They just begin, each one begins to swell over the years, and that's how the Joshua tree grows in girth. They just get larger from the swelling. Okay, so I've been there probably 10 or a dozen times. I don't have a whole lot of Joshua tree to show for it, and I usually spend a couple, 3 days there. In fact, I'm leaving for there tomorrow morning. And every time I've gone there, this wild stallion is right over there watching me. And I like to think of him as kind of my buddy. But he's probably not. He's probably not. He's probably watching me. He wants to know if I'm competition. He's checking me out. And maybe he's checking me out to see whether or not I'm following the American Federation of Mineralogical Society's rules and ethics for collecting rocks. Take only what you can use. Let's make sure that in addition to Petrified Forest National Park for our great-great-great-great-grandchildren, that those kids also have a chance, like we do, to go out in the desert and find some rocks. So take only what you can really use. I've gone to a lot of estate sales where there's big piles of rocks in the backyard. That must have been exciting when they picked them up in the field, but then they just brought them home and put them in the backyard. Anytime you're filling up holes, the animals of the area would greatly appreciate it if you fill them back in after digging. If you're collecting on government land for petrified wood, it's 25 pounds a day plus a piece, not to exceed 250 pounds per year plus a piece. What's the plus a piece? The plus one piece means that if you find a 40-pound log, you can collect it on your first day. If you have a 300-pound log, you can still bring that home and not exceed the legal limit. So it allows you to go over the limit with one piece. And lastly, well, not lastly, don't be a litter bug, please. And lastly, learn something about the rocks that you collect. It really does enhance your collection, especially when you're sharing it with someone else, to be able to tell them some background stories about the rock itself. So in summary, let me wrap up by saying, I hope I've convinced you that it's fun to collect knowledge along with the rocks or even in lieu of the rocks. And that every field trip doesn't have to result in major tonnage of material coming home with you. That choose the best and leave the rest is always a good adage to follow. Localities, and I've tried to list 5 of them, where collecting is either prohibited or really limited for one reason or another, those localities can be just as interesting as the localities which can produce a lot of specimens to choose from. So when I'm already repeating myself, collection is always more interesting if you can tell somebody something about it. So that's it for me. I want to give you a paraphrase of a quote from Peter Zodak, who was the founder of Rocks and Minerals magazine. Rocks and Minerals is a bi-monthly or every 2 months magazine with trying to fulfill all rockhound dreams. So they cover some minerals, some fossils, some lapidary materials, etc. Buy a good book about your collecting interest and then use it. So that's it for me. I'd be happy to answer any questions that might have come up. Wayne?
Do you have the book, Hoadley's book on
I do.
Petrified wood?
I
Is
do.
that not a
The
pretty
question
good-
was, do I have Hoadley's book? Hoadley was a wood anatomist who produced a book identifying simple steps in identifying wood. And he did it for antique furniture dealers. That was the primary audience that he was aiming at. So that antique furniture dealers, and Barbara's holding up a copy in the back of the room. Thank you, Barbara.
It's in our library.
We have it in our library. And most of those, the photomicrographs of wood anatomy that are in that book can be easily translated to fossil woods that you find. They're not going to be the same species, but they will be in the same genus and the same family. Other questions? Yes, Galen?
When I was up at the Alex McDonald Ranch in Oregon, I was able to collect a couple of pieces. It almost seemed like we were collecting obviously opalized wood, but it seemed like there was actually like original bark around the outside of the
Okay.
stuff. I mean, was that literally bark or something else, or what could that have been?
Okay, so the question was, when he was up at McDonald's Ranch in Oregon at the Madras show, I presume,
Field.
you went collecting out at Alex McDonald's Ranch, and it seemed that a lot of the petrified wood and the logs you found had actual bark surrounding it. Okay?
Something like that.
Is that possible? And the answer is, it is possible that a lot of, let me put it this way. If you look on eBay and see how much petrified wood is for sale with all the bark around it, you would think that almost all petrified wood had bark. But indeed it does not. And I would say at Alex McDonald's Ranch, I have seen some pieces from there, sequoias, that had a little bit of bark. But we know how thick sequoia bark is, right? Sequoia has really thick bark because it's fire dependent. It's fire dependent. It depends on fire coming through and wiping out the competition every once in a while. And the way it protects itself from fire is by having really thick bark. Did you see really thick bark up there, or was it just a little narrow band?
No, the pieces that I'm remembering, and this is a while back, it seemed like there was like, maybe a good 16th to an 1/8 of an inch.
Yeah,
thick
16th to an
skin
1/8 of an
almost
inch,
all the way around.
It is not what I would call bark. Lots of times what you're seeing on the outside is leaching by water and what I would call weak acids like carbonic acid in the water that actually creates a narrow band of a different color on the outside. And at the break, come up and I'll draw you a diagram of what you should see in the bark. The sieve tubes in bark is what brings the sugars back down to the roots. You know, the way trees work, water and nutrients come up the water vessels that are in the wood. They get into the leaf uses that water and those nutrients in order to manufacture sugars. Think maple syrup here, right? And it sends that sugar back down in the bark in what are called sieve tubes. Remember, when you're making maple syrup or when you're capturing maple syrup, you would be cutting a V in the bark, putting a pail below it, and the tree will just bleed out of the bark maple syrup into your bucket. And that's because it's taking sugars back down into the roots. The roots have the function of converting those sugars into starches, because starches aren't nearly as attractive to all of the things underground that would like to be eating the sugars, okay? So it converts them into starches and saves them for the next year when it can break them down and send them back up to the leaves as nutrients. And that's what initially gets the leaves started to grow. So that's a long answer to your question. Other questions? Gene?
Where would one find that, what you were talking about, the Clark on that?
Yeah, it had to be another petrified wood nut that would ask a question like that. The question was, where can one find this woods of the Eocene nut beds? You need some bedside reading there, Gene. This is actually available from the International Association of Wood Anatomists. They're located in the University of Leiden in the Netherlands. But the good news is that Stephen Wolf, who's a dealer at various shows that we see him at, he bought a box full because the shipping is so expensive for individual copies from the Netherlands. So you could probably get a copy at a reasonable price from Stephen Wolf. Any other questions? Okay, well, that's it for me. You are welcome to come up during the break, look at the Petrified wood.
Thank you, Jim. Also, just a reminder, the nominating committee has formed. Well, she's in there. But if you would like to run for a position as an officer in anything, please talk to Barbara Billieu, right in the back there. And also the Christmas party. There's going to be sign-ups for the Christmas parties. It's $10 a person. And Mary, stand up.
Yes.
And talk to this beautiful woman right here, or lady.
Sign up.
And Dee, we'll have fun.
We signed up.
How long would?
You've been to Calistoga?
I have.
And what, is that Miocene or Oligocene?
I think it's actually Oligocene. Yeah, it's almost exclusively